Hi viewers, this is Sri Ramlu. So today's topic is energy bands in solids. So definition: a set of closely packed energy level is called as energy band. Or there is another definition: the range of energies possessed by an electrons in a solid is also known as energy bands. Okay, either that is a set of closed packed energy levels, or that is a range of energies, also called as energy bands. And see, let me explain one by one. Consider a single isolated atom of silicon. So here I have taken example as a silicon only. Each silicon atom has 14 electrons. So we know the silicon, we denote it with Si, and its number is 14. 2 of electrons occupies K shell, and 8 occupies the L shell, and 4 occupies 4 electrons occupies the M shells. Okay, M shells. And here generally we denote them in terms of structure, how you know, like this. Okay, so in this manner, here it is a first shell, so it's the first shell, second shell, and third shell. In the first shell name is a K shell, second shell name is a L shell, and third shell name is M shell. And what he is saying, in K shell how many electrons are there? Only 2 electrons. So here 2 electrons. So 2 electrons present in which orbital subshell, you know, in a subshell. That is also given in terms of electronic configuration also. Okay, in L shell how many electrons are there? In L shell 8 electrons are there. In M shell 4 electrons are there. So like this. Now if you count them, 2 plus 8 10, 10 plus 4 14. So like this total number of electrons are 14. Okay, according to electronic configuration. And see here, in M shell only 4 electrons are there. Okay, according to configuration, its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p, 3p, 3s, 2p6, 3s2, and 3p2. Okay, so here the last cell is a third cell. Third cell is what? Sub cell. Its name is M shell. Okay, in M shell how many orbitals are there? 2 orbitals. One is a S and P orbitals. Now check it. We know that 2 electrons of M shells are in 3s orbital. See, in 3s subshell, and 2 are in 3p. That is 3p subshell is half filled. Here in S, generally in S maximum electrons are 2 only. Its capacity to fill the maximum electrons 2 only. But in P has a maximum number of electron capacity is 6. Out of 6, how many are there? 2 are filled. Okay, so 6th one is a half filled. Right? So half filled because it can accommodate a total of 6 electrons. So it has a capacity to keep a 6 electron only. Each shell has its own energy level. It is shown in the figure 1. See the figures. So it is a figure. Okay, so this is the figure. In this figure, it is belongs to the first cell, second cell, third cell. So like this, and above like this present many cells. Okay, so when atom is in isolated state means single atom. For single atom, isolated atom means for single atom only. And now, how can we denote these energy levels? You know, so just now I have drawn the structure in terms of circular or circular orbits. So let it is a silicon having the K shell, L shell, and M shell. So K shell is the first cell. Its corresponding energy level is denoted by it is like this. Okay, it is with help of the straight line. And L shell is denoted by in this manner. Why? Because it is second energy level. Okay, it is also completely filled. So that is why it is filled is given. And M shell is given, that is the third. So here above shells are there. Okay, so above shells has not completely filled. They are incomplete filled. And here each atom can have like this number, like this energy levels. So each atom has a each atom has their own energy levels in this manner. Suppose if we take a solid and that solid is prepared with the silicon, then that solid may contains a large number of silicon atoms, and each atom has like this energy level. Then large number of atom also has all the electron have these type of energy levels. Then they may present very near to each other inside the solid. Then their energy levels, what happens, they may intermix. Okay, intermix, and first level of the other atoms also mix with this, and with this second level and third level, like this they intermix. Then here set of energy levels will present. This set of energy level is called what? Energy band. So that is a given above definition, or it is a energy range also. All the K shell can never have the same energy. They may have the small difference. Okay, that is why there you may find a set of energy level. That energy level set is called energy band. Okay, now once again see here, each cell has its own energy level, it is shown. So it is for single. And next, now consider a silicon atom in a solid. In the solid, say that atom is containing 200 atoms, that's solid contains 200 atoms. Then there would be 200 K cells differing in energy by extremely small amount, not big gap, very small. This reason being that no two electrons are in this state, in this cell, see exactly the same charge environment. So you cannot find the same charge environment. Okay, and here the 200 K cells differ in extremely small amounts of energy are so close as to merge into one energy band. So what I said just above, here all the K cell energy level may meet here like this. They may contains like this. It is belongs to K shell, it is belongs to L shell, it is belongs to M shell. Okay, M shell is not completely filled. Okay, here it is filled, and this is also filled, first filled and second filled, but third one is not completely filled. So that is why in the third band, it is a third band. Band is means it contains a large number of energy levels. Okay, it is an incomplete one, right? This is called first band as shown in figure 1. Similarly, second orbit electrons have formed second band, energy band, and so on like this. So second orbit electron form this band, and third orbit electron can form this band, last band. So like this large number of bands can be formed. Now, and here we can say, here third band is in silicon, it is the last band. In silicon, third band is last band. So last band also has certain energy levels, energy range. Okay, so that is why it is shown this much of thickness. Okay, so this thickness is indicates it has energy levels, range, energy range. So it is the last one, and this last one is called what? Valency band. Okay, valency band. Why? Because suppose if we have the silicon like this, and around the silicon how many cells present? 3 cells. 3 cells. One is a K, L, and M. M shell containing how many number of electrons? Only 4. Okay, so these 4 electrons are in M cell. M cell is the last cell for this atom. Last cell of the atom is called valency cell. Okay, last cell cell is called valency cell or outermost cell. Okay, that is why energy level corresponding to, or energy bands corresponding to valency cell is called valency band. Okay, energy levels corresponding to valency cell is called valency band. Okay, so valency band we write VB. Okay, now see, right here the valency band. What is the valency band? The range of energy possessed by valency electrons is known as valency band. Okay, so it is a range of energy. So every band has a certain range of energy levels. So that is why if they are formed with the valence electron, that is called valence band. If they are formed with the free electron, that is called conduction band. Okay, so that is simple things only. Okay, in general the valency band has electrons of highest energy. It is either completely filled or partially filled. Okay, so valency band, it sometime it may completely filled or sometime it partially filled. So when it is completely filled, when that is a dielectric or that is a insulator. So for insulating material only valency band completely filled. For metals it is partially filled. Okay, but it never empty. See here bands clearly, right? So here the bands is, it is a valency band. Now conduction band, the range of energies possessed by free electrons, so it is because of free electron, is known as conduction band. So generally when we get the free electron, suppose it is a atom, right? So it contains like this. So it is a silicon atom. So here 2, 8 and here 4 electron present. The last cell electron contains only 4 electrons. So if you give the energy to these cell, then what happens? Electron come outside. And these 4 electrons are loosely bind with the nucleus. Loosely bind with the nucleus. If you give the small amount of energy, then what happens? They come outside easily. Then they cannot undergo any attraction of the nucleus. Then they move freely. That freely moving electrons are called free electrons. So free electrons are not controls of any nucleus. Okay, so free electron also called as sometime conduction electrons. Why? Because they conduct electricity. The conduction band is generally either partially filled or empty. It may be filled or it may empty. So it is like this conduction band. And conduction band always lies above the valency band. That is the important thing. Conduction band always lies above the valency band. Okay, next, forbidden energy gap. The separation between conduction band and a valency band is known as forbidden energy gap. It is a gap between valency band and conduction band. Now see the clearly. Forbidden energy gap is a gap between conduction band and valency band. So this gap is forbidden energy gap. Okay, so like this friends. So don't forget watching this video till the end and subscribing. Okay friends, thank you.